So I have met the Prime Minister a couple of times, been to number 10 a couple of times, all on advisory capacity. So on 26th, 27th of March, we tested 0 samples. Now we are approaching 6 million samples tested. In April, we were testing 50 to 100 samples a day. Now we are testing 70,000 samples a day.
Before moving on to the introduction, a quick reminder to hit that subscribe button. And without any further ado, virology is the career up for discussion in today's podcast. In today's world of COVID-19, virology as a career is gaining a lot of attraction. Our guest today is a medical virologist consultant at the South London Specialist Virology Centre. As the lead clinical advisor for COVID mass testing at Lighthouse Labs in the UK, he recently met the UK Prime Minister Borris Johnson. He is also the member of the Medical Virology Speciality Advisory Committee. It is my pleasure to welcome Dr. Malur Sudhanva on today's podcast and discuss with him the journey of his job. You are listening to The Career Show, a podcast that helps you find the right career and inspires you to follow your passion. My name is Trishan Kansrajani, and I'm a student seeking answers to career-based questions that we all have. I'm here to sit down with career specialists and talk to them about the lessons learned during the journey of their career. So I wanted to start off by asking you what got you interested in the field of virology. You mentioned to me that there are only 55 virologists in the UK, which tells me it's a niche career. So what got you interested in it?
Well, there are clinical virologists and academic virologists. There are only about 43 to 50 odd medical virologists in UK. So I'm a medical virologist. So what got me interested is, as a medical student, I was so fascinated by microbes, the way you detect the microbes to identify them. I thought it's like being Sherlock Holmes. So being of the impressionable age, I focused my studies in microbiology in my medical school. And so in fact, I did get distinction in microbiology. And then when it was time to do post-graduation, I got into JIPMER Pondicherry, where I realized virology sits within microbiology. Microbiology has parasitology, mycology, bacteriology. But virology is one specialty where the results are quicker and faster, and it was going into the molecular stream. So I thought that's my field. That's how I landed up with virology.
You just mentioned there are academic virologists and there are clinical virologists. Do you want to quickly explain the difference between the two?
Yeah, totally different, but linked. They work in symbiosis. For example, academic virologists discover the viruses like hepatitis C, HIV, the new influenza virus that came in 2009. Once they discover the virus and tell whether it's an RNA virus or a DNA virus, what the proteins are, how we grow them, or how we identify the virus, then the clinical virologists take over and we deal with the patient samples. So academic virologists are primarily employed by universities and do grant-funded research, and then they teach undergraduates and the postgraduates. And they have, as I mentioned, they have links to clinical virologists. The clinical virologists primarily work in a hospital setting in UK, for example, NHS Trust or in Public Health England, and they deal with patient sample processing, the reporting, the interpreting, management, infection control, treatment. Then we also do a little bit of research and audit. It depends on our jobs are actually timed. And we do, some of those have strong links with the local university. We do the teaching. And we do conduct research now and then, but not frequently. So we are more in the patient pathway than academic virologists. So we do work closely with them. We appreciate what they do. So there's a difference between academic and clinical virologists. They're not the same.
So right off college or graduation, does a student get the opportunity to choose whether he wants to become an academic virologist or a clinical virologist, or is he assigned one automatically?
There are two streams to get into virology. I'm talking about human virology. There's a plant virology. There's other in the things in the industry, like how you make your beer or various fermentations, the very exotic stuff. So I'll speak on the human virology. You have two different streams of entry. One is you become a medical graduate and enter. The other one is you do your BSc, MSc, PhD, and then you enter. So that's your clinical scientist, non-medical side. So once you enter, then there will be a fork where you have to decide, do you want to go on the clinical side or the academic side? And that happens very clearly in the medical field, where the medical virologists, they become, at least in UK, they become specialist trainees. So they have to do their medical degree, they have to do their MRCP, then they become eligible to get in. And when they get into the specialist trainee program, they have a chance to become an academic virologist or a clinical virologist. And that's how they get in. And then during the training, they do the FRC path exam. Whereas the clinical scientists, whom are the non-medical team, they will do their BSc, MSc, PhD, get into the training program, and then they can get into the clinical virology stream or the academic virology stream. But in the end, to become a clinical virologist, you must do your FRC path exam in UK. That's the UK rules. You don't have to do that if you are an academic virologist and a clinical scientist. You can, with your PhD, you can carry on. So it's slightly different at the same time, it's related at the same time, different. So,
in terms of the education aspect of it, what are the different crucial exams required to become a virologist?
Okay, I will divide my answer into UK situation and then for the overseas situation. That way it's very clear. So as I mentioned, you have to do your FRC path exams in microbiology or virology. And there are different streams completely. I'll focus on the virology component. So after 1 or 2 years of being a trainee, you take your part 1 exams, which encompasses infectious diseases, microbiology, parasitology, microbiology, and virology. This is like a common exam. And then you continue your training, having passed that. And then you do your FRC path part 2, which is a bit more vigorous in the sense that we test the trainees, candidates taking the exams so that they can become independent practitioners with no supervision. That means they take the responsibilities for the clinical, the scientific, and the management decisions. Now, that's your FRC path part 1, FRC path part 2, the virology stream. For overseas candidates, usually depending on what their local microbiology training program is, they do that. For example, in Indians, they do the MD in microbiology, but that will not train them to take the part 2 exam at all. It will help them to take the part 1 exam, which they can easily clear because it's theoretical. And then they have to have some exposure to the UK system. And let's say for at least for 3 months in 2 different labs, because the practice varies, not just one lab, just come and visit, observe, and then start reading about how to pass the exam. It is very important. The candidate taking the part 2 takes the responsibility for the entire laboratory. Only when they understand that, then they can pass their part 2 exam. It's not just simple study in the books and then you pass. It's about management skills, scientific skills, technical skills, and people skills. So yeah, it's multiple things.
You just mentioned how hard it can be to pass this exam. I remember you mentioning to me earlier that it's a really small percentage of people that actually pass the exam. So yes. Can you give them some tips on how to prepare for this exam that will definitely or will increase the likeliness of them passing the exam?
It is given that you read everything that's out there, every journal, that's recent one. You read all the UK guidelines because this is a FRC path exam designed for UK postgraduates. So that means we make no allowance for you not knowing because you don't know where the passing candidate will get employed eventually. Yeah, correct. They may get employed in UK. So patient safety is first. The ability to manage a laboratory is very important. So you not only look at aspects such as the clinical side of things, you also look at the people side, you look at the business side, you look at the lean, the workflow, you look at the medical legal side of things, every aspect of way the NHS virology here, clinical virology is practiced. So these are all given in, for example, if you go to the gov.uk website, you have various guidelines which keep changing. If you look at the SARS-CoV-2, for example, the pandemic, the guidelines keep changing every 1 or 2 months. So we have to be up to date with that. You have the NICE guidance. You have various European and UK-wide societies or colleges where they produce guidelines. So you should be familiar with all these things. And that will help you focus on what is the best for your patient. So the tips are easy to summarize like this, but actually it is extensive and it's one of the hardest exams in the world to pass.
Well, I'm sure that kind of advice will definitely help our listeners to work on that exam. But I want to shift gears and talk about COVID-19. In today's world of COVID-19, the work of a clinical virologist has never been this important. What, according to you, is about this virus that has baffled us so much?
Well, where can I start? This virus has exposed the underbelly of the human society. And you're aware of that. Everybody's aware of that. From the human angle, I'll talk about the human angle first and then go into the virus. Human angle is, I didn't know there are so many people who can run conspiracy theories and run it across WhatsApp. And I didn't know there were so many armchair virologists who are ready to give an opinion on everything. I didn't know the economy of so many nations get battered, but the nations like New Zealand and Australia and China and Taiwan, for example, who hunkered down and didn't allow the visitors in at all, they are the only ones to actually stop the social distancing and actually have a normal life. We didn't know that. And as you know, in the last 24 hours, we didn't know that it will change a presidential race in US. So this is the human angle, which I didn't know. It's a baffling thing. So let's go back to some more basic virology. So every aspect of the virus has baffled us, and only time is going to make us wiser. Almost everything that I believed that was true on one day was not true 4 to 6 weeks down the line or 1 or 2 months down the line. We had to look at evidence all the time and change our practices. Just as true scientists, we did challenges. So we were told human-to-human transmission does not occur. We know it does. We were told it's like influenza regarding mortality, but that was wrong. We were told there was no airborne transmission. That was wrong. We were told mask is only a Southeast Asian or East Asian Oriental thingy. We don't do it in Europe and US. That is wrong. We were told dozens of new drugs and repurposed drugs would cure the virus, but that was completely wrong. We just know at this point in time, steroids are the only ones have an efficacy. Of course, there are others which are there, but with conflicting evidence. We were told that development of IgG means immunity, but that was wrong. We were told herd immunity works. Let's ever get everyone infected. And in Sweden, we know that's wrong. There are hundreds of vaccines on trials and some of them bogus ones. And we know that is all it's still infancy. It'll be a while before those things come in. Now, the one thing, however, we are sure about, and this is not baffling, this is fairly straightforward, is the virus is here to stay. So there is one particular virus. I'll give you an example. It's called human coronavirus OC43. This started as a bovine pandemic in 1880, 1889, 1890, 130 years ago. And then there is a human pandemic in 1890s. Guess what? That virus is still with us and it causes common cold. So this virus, what we have SARS-CoV-2 also, because it transmits so easily and in majority of people, it causes very little clinical features. Eventually, I'm not saying now, I'm not saying the next year, I'm not saying the next 2 years. It's beyond our lifetime, it will become a common cold virus. So that's your summary. The baffling and the mysteries and so many unknowns, but we know so many things now than what we knew about 8-9 months ago.
There were so many theories that were proven wrong. For example, the mask aspect of it, the airborne aspect of it, the human transmission aspect of it. How was it dealing through those aspects one by one and being there when those theories were being proven wrong?
So what I tend to do is, number one is, don't believe one article. You have to believe when it's reproduced in other places. Luckily, in UK and in Europe and US, we have a whole team of people who look at the literature and then sift through it and tell us how strong the evidence is and change the guidance. Me being a clinical virologist, if you remember in March, April, we had a crisis here of testing and we had to focus on the testing. I had to focus my energies completely on the testing side of things. And the work done by other academic virologists across the world, the physicians across the world, and the publications, the rapidity of publications, even then the quality of publications varied from country to country, place to place, and that helped us. That evidence that presented were into a guidance, sometimes sifted through our weekly video conferences that happen within UK. All these helped us to digest. And it's not just a UK phenomenon, it's happened in every country. There are a lot of noise. And of course, the armchair virologists and the public opinion, for some reason, it mattered this time. So with all this noise in the background, we had to sift through it. We had teams of people working on it. It helped us a lot so that we could focus on what we are good at.
You just spoke about testing. And like I mentioned in my introduction, you're the lead clinical advisor for Lighthouse Labs, which is the COVID mass testing lab in the UK. You have recently advised on the setting up of various COVID testing centers across the UK, which has increased the diagnostic efficiency across the country. So do you want to talk about how you went about this process and what are the challenges you faced during this process?
Yeah, thanks for mentioning that. So I primarily advised the Milton Keynes Lighthouse Laboratory in the middle of England. So here on 26th, 27th of March, we tested 0 samples. Now we are approaching 6 million samples tested. In April, we were testing 50 to 100 samples a day. Now we are testing 70,000 samples a day. And by December, we will be testing 220,000 samples a day. So you can imagine how a complex laboratory was set up.
And this is only one laboratory, correct?
This is just one lab. Like that, you have other labs in Glasgow and in Belfast and in Manchester and Cambridge and now in Newport. So I'm also writing up the workflow, which is the first in the world, where we are going from, I don't know whether we can call it a giga lab, from mega lab to a giga lab. So we could test anywhere from 220 to 300,000 samples per day. And this model will be replicated across UK. And this will be the scalability of this, the logistics of this was an enormous problem. It is solved by the help of the Army and the Deloitte and the Department of Health. There was a people problem, employing people, that was again solved by the universities who came in and a lot of volunteers who came in. There were equipment problem, getting the equipment into the laboratories. So a lot of universities contributed equipment to help start the whole thing. The space had to be reconfigured very, very swiftly. The whole laboratory was built within a shell. It was built within a matter of 2 weeks. And in the last 8 months, we have remodeled it 3 times. The third remodeling is happening now so that we can go from 70,000 to 220,000 in a matter of weeks now. And all these things are done where you had the directive from Department of Health, produce this capacity. And the professionals inside the lab, some of them are real geniuses. The decisions were done not by committees, by 2 or 3 people, very clever people, dedicated people sitting together and coming up with plans as to how to get on with things. Less bureaucracy, very, very efficient in the whole thing. It also means the workflow. We have to plan the building and the equipment location according to the workflow. Then, of course, PCR has various aspects, the extraction, the amplification, and detection. Suddenly, we have a problem. We had a problem where, how do you open 70,000 samples because they're all packaged? Suddenly, the laboratory aspects became smaller. How do you open a package has become a bigger problem for us, which we kind of anticipated, but the enormity of the problem, we solved those things. And of course, when the amplification happened, it comes out of the results, come out you need to have machine learning software so that a person doesn't sit in front of the computer and pressing buttons. It has to be automated. So we have automated that whole thing. That means the results and then the results get exported to NHS digital and to the patients. And when you do all these things, the quality is at the back of the mind. We have to make sure the assay is the most sensitive assay and it's reliable. So that means we need to put in checks to monitor it, external quality assessment, internal quality assessment, all the things that you would expect in a laboratory. And of course, in the middle of all these things, we had adverse media. So finally, we are here with the cusp of I don't know whether you can call it like a Cambrian explosion so we are on the cusp now, at least in the Milton Keynes lab, where we are set to explode from 70,000 per day to 220,000 per day. This is a brand new workflow using something called LGC endpoint PCR. And that will happen in a matter of days now. The construction is happening and we will reach 220,000. So it's been a fantastic challenge, a lot of sleepless nights, a lot of crazy problems solved, all done in a group of professionals who are so dedicated. So I just advise there are people who do the operational side of things, who are very, very good at these things, and they are the ones who made it happen. So that's a good summary for you.
Well, that definitely was, and congratulations to you and your team for doing such an amazing job. But let's switch gears and talk about the different kind of people virologists work with. In your answer, you just mentioned that you required help to set up machine learning softwares. Deloitte was helping you with consulting. So I wanted to understand what are the different kind of people a virologist works with.
Well, I'll divide my answer into if you're a hospital microbiologist, NHS, and then the Lighthouse, it's totally different, but they're all kind of linked. So it's the spectrum of people we deal with is wide. It's across the society. Organization-wise, it could be your local hospital, your general practice, your public health, local public health, or national public health, occupational health, because occupational health is in every industry. That means we are linked to every industry. Department of Health, of course, and then pharmaceutical industry and the vaccine industry and every. So when I say every possible industry, if someone has to get employed into any industry, one of the things is there will be occupational health. So if there's anything to do with the human samples being tested in a particular facility or manufactured, the occupational health clearance is primarily a virological testing. And that's where we come in and the complications that arise because of that. Range of people include the junior most trainee nurse or doctor in a hospital, the senior consultants, the medical directors, the clinical directors within the hospital, the chief executives, then of course the public health officials and the midwives who could be in the community or in the hospital, and of course a lot of politicians. So I have met the Prime Minister a couple of times, been to number 10 a couple of times, all on advisory capacity. So it is being professional about all these interactions, not getting carried away to think that you are ruling the world, because there's always someone who comes with you with an angle which is completely different from what you were exposed to all this time, and we have to find answers. So that's in the current pandemic. So we've seen this in the previous, in the 2009 influenza pandemic also. In the current pandemic, that whole thing is amplified even more. There's more focus on what we do. And so the interactions I've had has been wide, varied on the media, but I try to not be on the media as much because it just increases the public profile. It's not good from my perspective. I want to be quiet in the background, carry on with my work. And this is a change for me, by the way. Anyway, so yeah, it's wide and varied.
Thank you for doing this. So I'm sure a lot of budding virologists will find this really helpful, especially in today's world where we really understand the importance of virology and the importance of studying virology. So what are you looking for in budding virologist when you are examining them during the FRC path exam?
In the FRC path exam, I did mention that we are looking for someone who can make decisions. The knowledge is never should be in a question. It's easy to know what are the positives and what are the negatives. That is given, but it is a gray area that makes you an expert. And that's what we are looking for in the FRC path exam. But that's the exit of your training program. But in the beginning, if someone wants to be a virologist, let's say a budding virologist, yeah, in that instance, the curiosity to question every clinical scenario and investigate is a must. Then you need to have a management skill to manage a large laboratory. That means you should be able to compartmentalize issues. And then whatever you learn today, that you need to take the chance where all those things will be changed in a matter of years. That means you need to welcome newer viruses, welcome new technologies, new antivirals, and all these things will change with time. So one of my consultant education supervisor in Glasgow, where I trained, she said when she started her medical school, hepatitis C did not exist. And then as a virologist, all she did was treat hepatitis C virus patients. And of course, now we are in a situation where, at least in UK, we are catching everyone with hepatitis C, and hardly any new infections come to fore. So in a matter of a lifetime of one's career, I've seen hepatitis C coming in and gradually disappearing, not becoming a matter of public health importance. It's still not there, but in a matter of days, years, it'll no longer be a problem. So we should be able to adapt. So that's my summary there for you.
So what is one advice you wish you had received when you were starting your journey as a clinical virologist?
Do the time management course very, very early on. That way you know how you can say yes to things you can do, say no to things you cannot do, manage your time so that you always have a very good work-life balance. This is true for any career, not just us. So unfortunately, that's something that's been, not many people are aware that a time management course is of such good use.
No, I completely agree with you, especially in today's world and today's era where we are offered so many things to do at a single given point of time. It is important to choose the things that are more important to do rather than the less important things. So thank you so much for your advice. Thank you once again for all your help with the COVID-19 testing in the UK. It's a huge achievement. And thank you for coming onto the show today and telling us more about virology. I'm sure a lot of budding virologists will find this helpful. And thank you once again for sharing the journey of your job.
Thank you very much for having me over. I have noticed that there has been increased demand within the UK community to become a virologist, clinical virologist / academic virologist, both. And I hope it happens worldwide, because this virus is here to stay and it's worldwide. The world needs more virologists, not less of them.
I hope you enjoyed this week's career discussion. Let me know your thoughts in the comment section. Also, don't forget to like, share, and subscribe. Your support means a lot.